video on rationalizing the denominator. It's part 2, actually, and we're going to add some addition and multiplication in this. So if you didn't see the other video, you should watch the first video on this. Let's get to it. So just to simplify this, you cannot have a radical in a fraction. So if we had, let's say we had 3 over the square root of 5, you just can't have a radical there, right? It's against the rule. So we're going to rationalize it like we did in the last video. We're going to do the square root of 5 on both sides, right? Because basically this is 1, so we're not changing anything. And remember, the square root of 5 is irrational, so we don't want irrational numbers. We want rational numbers, right? And we're going to create a rational number. We're going to have 3, the square root of 5 on top, which is fine. We can have that. And the square root of 5 times the square root of 5 is 25. It's the square root of 25, which we know is 5. And I'm sure you're seeing the pattern now, right? You don't even need to do the square root of 5. So this is our answer, right? We rationalized it. Now, we can do multiplication with this also. So let's do some multiplication. Let's say we had 3, the square root of 7, and we want to times it by, let's say, 2, the square root of 5. So first we should rationalize the fraction here, right? So I'm going to say, we'll just bring this down, right? We'll have 3 square root of 7, and we'll times it by the square root of 7 on both sides, right? And here we're going to get 3 square root of 7 over 7, because 7 times 7 is 49. So we rationalize this one already, and then we'll multiply it by rationalizing the other one. This gets very messy too. So let's rationalize the square root of 2 and the square root of 5. And then we'll put it all together. So let's do it like this. We have 2, the square root of 5, and we're going to times it by the square root of 5 on both sides. And we'll get 2, the square root of 5 over 5. So let's take what we had before. We had 3 square root of 7 over 7 times 2 square root of 5 over 5. And we just multiply now, because we got rid of our irrational numbers, and we have rational numbers now. We got rid of the radicals. And so this will be 3 times 2 is 6, so it's going to be 6 square root of 35 over 35. All right, let's see if we can do this one now. What if I gave you 2 square root of 3, and we times it by the square root of 2 over the square root of 7. So what about this one? Well, here's something you should know. When you have 2 radicals like this, you can also write it like this. I'm just going to show you. I'll bring it up here more. So I'll put an arrow here. This can also be square root of 2/7. Bring that down. There we go. It's also the square root of 2/7. But for now, we're going to just solve it like we would rationalize anything else. So let's do 2/3 first. We're going to rationalize it, timesing the square root of 3 on both sides. On the top and the bottom, that is. Numerator and denominator. And we're going to get 2 square root of 3 over 9. So that's our first one. And this, we'll do the same thing. We'll do the square root of 7 on both sides. Square root of 2 times the square root of 7 is the square root of 14. Over the square root of 49, which is just 7. So let's write this one out. We have 2, the square root of 3 over 3, not 9, actually, that's a square root of 9. Square root of 9, which is 3. Always double check. And we're timesing it by square root of 14 over 7. Square root of 14 over 7. And that's going to give us 2 square root of 42 over 21. Very important to double check. It's so easy to make a happy accident, as Bob Ross used to say. So again, it wasn't 9, it was the square root of 9, and that was 3. All right, let's get a little more challenging here. Let's look at a variable. How would we rationalize a variable inside a radical? Like, let's say we had 5 square root of 2, and then we had 7 square root of 7x. Well, this is irrational, even with a variable, so we're going to just times 7x the same way. Nothing different. Just that x is going along for the ride. Let's lift this up so you see it. Okay? So this will give us 5. We have that 5 on the outside. And it'll be the square root of 14x. Right? And over here we're going to have 7. And the square root of 7 times 7 is 49x squared. And we can break that down. We'll bring it down over here. So we're going to have 5 square root of 14x over 7 times 7 times x. And the final answer will be 5, the square root of 14, over 49x. So that's if we had a variable in the denominator. Alright, so we did multiplication. Let's do some addition. Addition is a little longer sometimes. So here's 2, the square root of 3. We'll start off with that. Plus 1, the square root of 5. Remember, in addition, let's look at some rules in addition before we go on. So just treat it like we would treat variables. Remember, we said x plus x is 2x, right? So if we said the square root of 2 plus the square root of 2, well, that's 2 square root of 2. It's not the square root of 4, right? This is not multiplication. And remember, we can't add unlike terms. Like the square root of 3 and the square root of 2, we can't add them together. That's like saying x plus y. And also be careful, let's say you had the square root of 2 plus the square root of 10. Right? You can't add that together too. And don't try to break down the square root of 10. Don't just say, well, it's the square root of 2 plus the square root of 5 plus the square root of 2. It's not plus. It's multiplication. So that's a common mistake. No, don't do this. So they cannot be broken down any further. So remember, you have to add like terms. So we're over here and we see we do not have like terms. So what do we do when we don't have like terms in addition? Same process, right? We have to find a common denominator. But before we do that, let's rationalize each term we have here. So we're going to do the 2 square root of 3. We're going to multiply by the square root of 3 on both sides. That will give us 2 square root of 3 over the square root of 9, which is just 3. So here's our first one. So we can write it here for now. We're going to say 2 square root of 3 over 3, and we'll plus it to the next thing we rationalize. So we're going to do the square root of 5 on both sides. And I mean top and bottom. So that gives us the square root of 5 over the square root of 25, which is just 5. So it's going to be the square root of 5 over 5. Okay, so we went from this, rationalized it, and we got this. Now we need a common denominator. And the common denominator is 15. So we can put a 15 over here, put a 15 over here. 3 goes into 15 5 times. 5 times 2 is 10. So we're going to have 10, the square root of 3. Everything's going to be over 15. Plus, what do you think? 5 goes into 15 3 times. So it'll be 3 square root of 5 over 15. Let's do some more addition. All right, erase this. So what if we had the square root of 2 over the square root of 5, right? And you want to plus it by the square root of 2 over the square root of 7. Now, like I said previously, when you see something like this, it's just the square root of the fraction 2/5 plus the square root of the fraction 2/7. And if you put this in a calculator, you'll get the same answer as what we're going to get in a minute. But let's just rationalize this and see if we can break it down a little further. So why don't you try to rationalize this and see what answer you get. Okay, so let's just bring it up here. So we have the square root of 2 over the square root of 5. Right, and we want to rationalize this. We're going to put the square root of 5 on both of the sides. Remember, we don't want the radical in the denominator. We don't care if it's in the numerator. So this is going to give us the square root of 10 over 5, right? Because square root of 5 times the square root of 5 is 25, and the square root of 25 is 5. So we have that one. Let's put a box around this for now. Let's do the other one. Square root of 2 over the square root of 7. All right, we'll rationalize it like we know we've been doing already. And we're going to get the square root of 14 over 7, because that'll give us a square root of 49. All right, so now we can add. We'll have 10 square root of 5, 10 5 now, the square root of 10 over 5. Always check your work. Plus the square root of 14 over 7, and we need a common denominator again. And the common denominator is 35. Lowest common denominator, right? Okay, so 5 goes into 35 7 times, so that's going to give us 7 square root of 10. Everything's going to be over 35. And 7 goes into 35 5 times, it was 5 square root of 14. So this is our answer. And it's also this that we've done before. Fix that too. Okay, now we can do subtraction. It's the same process if we do subtraction. So let's look at a subtraction problem. Square root of 4/5 minus the square root of 3/4. So we see it. Clean that up a little. So remember what I said. This could be broken down into the square root of 4 over the square root of 5 minus the square root of 3 over the square root of 4. Now we can't have irrational numbers or radicals, right? But the square root of 4 is rational. What is the square root of 4? It's 2. So this could change. This could change right away. Okay, well, this is, as we have a little hurricane there. Square root of 2, square root of 4 is 2, and the square root of 4 is 2. So this changes right there. So what's our next step? Rationalize each one. We don't have to rationalize this one. This is good already. This one's good. Check mark for that guy. Okay, so then what we do, here we go. We said this one is already good. Good to go, right? So we take this, we got to rationalize 2 square root of 5, and this is what we got. 2 square root of 5 over 5. And then we look for a common denominator, which is 10. So we have a 10 on both sides. 5 goes into 10 twice. 2 times 2 is 4. So we'll bring this up. Here's our answer here. 4 square root of 5. Everything's going to be over 10. 2 goes into 10 5 times. And we're subtracting here, remember. And this is our final answer. Right there. All right. That's our video for today.